Because the dimensions of the monitors and that of the gap between the two overlapping ends of the spiral are identical, the blank disk exists and is confined within the boundaries of this empty space. The parameters of the sculptural elements are defined by those of the existing architecture. The size of the black wooden panels correspond exactly to the height and width of the room's doorway. The two panels are set symmetrically in relation to the central axis of the room. In contrast to real doors that integrate with the wall, these panels lie parallel and a small but specific distance away from the wall. These specific distances between the wall and the panels are defined by the insertion of two monitors, one for each panel, in two different orientations. One monitor is orientated with its largest dimension in a vertical position, defining a narrow space. The other monitor is orientated with its longest dimension in a horizontal position, defining a slightly wider space. The addition of a mirrored surface on the inside face of the panels creates the illusion of an extension to the actual space. This creates a tension of opposition. Image and reflection exist within this enclosed sphere, indistinguishable one from the other. All sculptural elements seem identical. This apparent similarity exists, except for a slight variation in the rotation of each monitor. These installations were realised in the museum at Fabriek in Mönchengladbach in 1991. They are part of a series of works that began in 1988, dealing with space and perception. All works consist of the same monitors and video animation, which are manipulated in a variety of ways.
This was part 2, and it's such a super instructive video tape that I need to add so many things. And the only thing I want to add is that there have been 3 stages of escape for the audience. One stage was they came in and thought, and it happened like that, they thought, oh, it looks like Richard Serra, because the museum in Mönchengladbach, and there have some Richard Serras. So then, that's looking like Richard Serra, okay. Outside again. And the others came in and thought, oh, there are 2 similar things, and there are video players somewhere in the room. So maybe there's something happening, and they had a look here and there. And they saw one monitor horizontal and one's vertical, and went down again, and you could only see the reflected space if you approached up to like 40 or 50 or 30 centimeters to the gap, otherwise you wouldn't have seen it. So probably only 5% of the visitors had seen the whole installation, maybe 30% had seen the reflection, had seen the monitors, and probably 50% left after being satisfied with some architectural thing like Richard Serra. And the last thing I want to speak about is, oh, I thought I stopped it.
The circular form fits perfectly within the smallest dimension of the monitor.
I'm sorry, it's auto repeat. Yeah, this is somebody unknown. Maybe it's Anthony Gaudi himself, and this is the hanging maquette for the church of Cologne Gül in Barcelona. And Colonia Gül is a housing district for workers, and there was some Comte de Gül who asked Antoni Gaudi to make a small church there. And the whole process of planning took over 12 years because he wanted to discover some new ideas about construction. And the way to discover the new ideas was by building hanging maquettes of the real thing. So the church actually looks like that. It's a very complex structure of arcs, pillars which have a form like trees and so on. But in fact the thing was built like that. So this is one of the few photographs existing from the original maquette. And it is something about, so the work on this maquette is something about passion, because first it took 10 years, and second it was all these hanging ties have these small sacks filled with lead, and the weight of the lead in the sacks is exactly fitting to the real weight which a church like that could have in this place. So the scale of the weights was 1 to 10,000, and the scale of the maquette was 1 to 10. And they started to build from here, of course, and came up to here, I don't know, for example. And when it turned out that they had a change in design, then they had to start the whole maquette from the beginning new, because that, if you have 1 ton of weight more here, that means there's also part of the ton somewhere here, you change the system. So we started to build and rebuild and build and rebuild this hanging maquette several times. And yeah, after a while, he started to build the real thing upside down, and he made photographs of the maquette, turned them upside down, oops, like this, and made collages as design drawings. And even for the construction, they took the measurements out of the maquette and made the construction exactly fitting to the maquette world. And what is interesting in this thing for me is that there is a mechanical rule in the thing that whatever is hanging is the perfect form to form if the weight is only the weight of its own. So if you take a tie of a certain distance and you put your fingers together, it's going to form a curve. And this curve is all the time based on the same formula, which is almost like a parabolic form, but it's not really a parabolic form. It has a formula. But to make it easier in this lecture, we call it parabolic form. And this is a reconstruction of the maquette, which was made at the Technical University in Delft in '78. And later there was a big exhibition, a traveling exhibition, shown in Zurich, Düsseldorf and Vienna, which was called Der Hang zum Gesamtkunstwerk. For that exhibition they had to rebuild the maquette, but then they are changing the style of building so that it can be transported, because if you imagine that it's shaking, all the lines are shaking, so it's probably destroyed just by changing its position for 1 meter. So they changed the scale of the weights from 1 to 10,000 to 1 to 100,000. So these sacks are much smaller than the sacks before. And of course they made some more modern links, so they used small steel things to fix them, because Gaudi used something which has almost no weight at all to be as perfect to the reality. And this thing was traveling around the world, and then I think now it's shown in Barcelona somewhere in the Gaudi Museum. And it was some, let's say that this maquette for this exhibition was a sort of international collaboration of scientists in architecture. So the Technical University of Delft worked for it, the Stuttgart Technical University worked for it, a Japanese university worked for it, So it was something like doing the big international thing by reconstructing this simple hanging maquette. And now it's something quite complicated about mechanic principles. If this is a beam and these are the bearings of the beam and there is some weight on it, of course the beam wants to bend like that. And then there are some tensions. So in the upper part of the beam, it wants to extend the beam, and in the lower part of the beam, it wants to compress the beam. No, it was opposite. Yes, it was opposite. In the lower part, it's extending the beam, and the upper part is compressing the beam. And on the other hand, there is some moment of circulation appearing. And this moment of circulation is the main problem in statics, and you have to try to get rid of that. And if the transfer of powers is going only horizontal or only inside the material itself, it's perfect, and then you can have the thinnest possible cross-section of materials. So you can see something else. It's like lesson 1 in mechanics. The thing is, of course, bending, and here it's a longer distance than up here. And of course, it's bending in a curve if it has no stable material of itself. And the more equal the weight is on it, the more it's going to form a parabolic form. If this is one of my few Dutch words, this is a fietsenkette, and this is hanging by itself, it's forming a parabolic form, and if you're very good, you can put it upside down and it's standing by itself. So this is the truth, and I'm sorry that I cannot really explain to you. This is the most perfect form for the roof of a big hall, and it's almost the same form which is used in the Fabriek. And the formula of this form is y is sinus of the height plus what is it? Multiplicated with the angle of x. Sounds strange, but this is the formula, and that's just a mathematical rule. And as you can see here, this is only a very thin plastic stripe which is pressed into these two angles, and it can hold a real extensive amount of weight, because this almost parabolic form is the most perfect form. And yes, of course, this is not my own investigation, this is just standard knowledge. And there is, for example, there's one of the biggest bridges of the century. It was built in 1926 until 1930, and it was the bridge with the broadest span until the end of the war. And as you can see, there are these three parabolic arcs which have a span of 168 meters each. And something quite nice about this bridge is that the negative form for building the concrete of the bridge is swimming like a ship to the place where it's used. So they made one form like that, and then they made the first arch, and then they transferred this arch to the next part of the bridge, to the next part of the bridge, and to repeat it, to remind you of the bridge, which is, yeah, that's the bridge. And that's the tool for doing the bridge. And this tool has, of course, some steel strings here, down there, horizontal, so that the two ends are not disappearing from each other, and the thing goes completely horizontal. And also the whole of the Fabriek would have these strings. And something else the same engineer did, it's called Eugene Freycinet. He is a big hole hanger for airplanes, which is about 80 meters high. And yes, it's a parabolic form again. And this is the system how to make the concrete. As you see the cross-section of each element, there are 40 elements with this V form, which are made by a traveling structure. So it took one day to make the concrete for the arch. Then they had to wait for 3 or 4 days. Then the whole system was transferred for 5 meters further, and then they did the next one, and the next one, and the next one. So it was about 2 months to build one hall like that. Became the standard form for almost every big span, until they invented something else which became more sophisticated, which is inside the construction by priests. I don't know how it's English. Yeah. But this is the last period of puristic engineering. That what you see is what you get like a computer. But you really see what is constructed. It was of course sponsored by the Allies in the war. And now we go into some sort of pornographic of engineering. This is a big hangar by Pietro Ingegneri, who is an Italian architect. And so you see the parabolic form is here and here, but he made a crossing of a rectangular crossing of parabolic forms. So it's not more that simple looking, but in fact it's still the same shape, which is responsible for the big span of the hall. And when this hall was finished, it looked like that. And from outside, it looked like that. So I claim that this was a sort of historic, heroic period of engineering when engineers made sculptures in a style which is, in most of the cases, more impressive than the sculptures of the period. But this is the link to my installation upstairs. So what I found was this so-called perfect-looking arch, and I don't know whether it's a parabolic form or not, because I didn't take the measurements. I was just taking the paper, hanging the paper, and because of the rules of mechanics, I know that my form is perfect. Whether the form which is existing is perfect or not, I do not care. It's up to the spectators, if they're interested in that, to compare if one of the firms is more perfect than the other. But I know my form is the most perfect in the world, because it's the natural hanging form. And as you see in this photograph, there are also in the hall upstairs, there's an axis of reflection, which is on 3 meters height. It's exactly there where the steel strings hold the two walls together. These steel strings could be something like an evidence that it's not a perfect form, because you shouldn't need these steel strings if it is a parabolic perfect form. But you never know if the form is not perfect or the walls are too thin. So there must be some reason why there are these strings, but I don't know. And I don't care, because it's the building, and my form is the most perfect form. But there's a difference in my installation if you compare it to this installation, because here the surface of the order is a surface where you can get to easily. But in the installation upstairs, the problem is that the axis of reflection is on 3 meters height, and you are never able to get up there. So the problem is that the perfect space, or that the reflection, the axis of the reflection is too high to get up there, and too high to check if there is a difference between the two forms, if somebody is interested in any difference. So one of my ideas in making the thing up there was that I create one form which looks almost like the other. No one knows if it's really like that. And that by accident, by the conditions of how the hall is built upside, there is no chance to give evidence whether it is working or not. And I want to close with a quotation of Gaudi, which is again not working, of course, because it's a German one. But so it's just like that. That Gaudi, of course, was Spanish, and he was as a Spanish, he had to be a Catholic, and he was a Catholic, and he was believing in Catholicism, and he was believing in God. And of course he was believing that every form which is based due to natural laws, or seemingly natural laws, and geometrical rules or mechanical rules is an expression of metaphoric, how do you call that? Yeah. Is an expression of the rules of God, how life has to be. So, he's funny, if I find it. So that is Anthony Gaudi's idea of the rules of God, and that is the end of the lecture. So thank you.
When you make this circle of motion, I was asking myself when you do this installation work, if you put it into installation work, what is there a difference for you? With this image in the monitor seems very clear to me. When it is in the installation, it seems like as if the installation is like a cloak, taking of it. It's like I don't know. I don't really see the sense of what does it add more to the image of the circle on the monitor?
It was
Or
like that.
do you use it as material just to make an installation?
No, I discovered the thing when I was thinking about video, and at the same time I was an architect still, so this was like my first installation. But I didn't show the very first installation of the series. The very first installation of the series is, I make a simplification of that, is a heavy body sitting on a very small monitor. So I have much smaller monitors than this one. My monitors have postcard size only, so the impact of the video is not that strong than this one, because it's so super tiny.
So it's not a video anymore?
No, it's not. It's
like
almost no
like
more.
an object itself, something. So it goes away from the video.
Yes, it disappears from video by the time, but it's still, everybody knows it's a video, so you read it as a tool out of media world. Even my monitors don't look like videos because I built them in boxes, so there is no Philips or Sony on my monitors anymore. And I can't demonstrate it with this one, but if this monitor would be on the ground and I would step on the top of the monitor and stand there, then this circular form will get some different meaning, because then it gets the simulation of a real form which is moving from one side to the other, and the one who stands on the monitor is seemingly moved from one side to the other in the opposite direction of the round form.
So you use this form as an architect?
Yes,
to make a space to reconstruct space, or to...
At the very beginning I was, this sounds banal, but I was impressed by the thing that bridges usually lay on round steel rolls. And the bridge is extended by temperature and by the moving of cars on them and so on, so that the bridge can move from one side to the other. So a very super heavy bridge is on such small rolls only. And this was one part of how to start a series. And the second part was that I read a lot of books about media stuff and so on. And later on, during using the thing, or by the experience of installations, I learned that there are some other impacts possible in the work, and then I used it in very different ways. So it was like I explained in one meeting, like Irving, when they use the signs, they use them so often in so different ways. The Irpin, the Yugoslavian group, but it's a bad example. I used this thing, had nothing to do with an I at the beginning, but later on, when I was in a group show, and all the artists had pieces on the walls, then I decided to do something on the ground. I made a small cross with the 4 monitors in each arm of the cross, facing to all 4 sides of the exhibition walls, and they were moving in parallel, so they were watching the space all the time. So in fact, my installation was the permanent visitor of the group show. And then I used it for the first time as something watching or lighting. Before I used it in a more in the engineering aspect. And later on, so like in the one which was shown last fall, it was only a tool for showing that if everything is the same, it's just one movement which makes the opposite. Of course, all the story of my installations is involved in the work that people do not know. For me, it was just important that I show them that everything is symmetrical. It's just one monitor upside down, and the other is the normal position. And there are the mirrors, and the mirrors make this opposite movement and the parallel movement. And at the same time, or before, almost before, I learned that usually people who go to art exhibitions are not very patient in watching the things. So I learned for myself. This 70% of idiots I don't care about. I care about the probably 20 or 10% which really are interested in the things. And for them, there are some special features in the work which are my real interests. So the thing is, and I don't know if I continue to work with that, is you know that I did. But I didn't show the same. I didn't want to repeat the lecture from the PPP again. Of everything, and not something moving in front of a neutral background, but it's an exchange of importance. And there, I can't explain that now, but there is an installation which show you that this is quite easy. If you build in this monitor in a box, and there's only a circular aperture to the screen, and you can only see the black image, then you won't see nothing. You won't see anything because it's nothing. It's no light. It's only the imperfectness of the screen
if you see
that you
this
see
eye,
something.
if you see this eye, then you see something moving in front of nothing.
Yes.
Because
But in fact, it's
the other way
opposite.
around,
Yes. In the concerning with the technical video, it's the opposite.
Yeah.
It's nothing moving in front of everything.
Moving something.
Yes, this is.
Just nothing.
There's a kind of black hole void, a sacred thing. And has it's quite a traditional image in that sense. And also, how is the relationship between that and the way that it was like hidden from the viewer to an extent? Because it wasn't needed to define the space behind it, because already the distance, but there was a distance, a gap between, for example, the board and the wall was defining that space.
No, it was only needed to show the difference of quality of this, that the one which was horizontal, but then it would have been out. That was the one which is horizontal meets his reflected image and disappears again. It's moving like that. And it's quite a simple way of demonstrating that. The one which is put upside down, which is moving vertical, is moving parallel to its reflection. So there's a quality of parallelity on the one side and the quality of opposition on the other side. And this is quite easily done by using a simple thing like that. Of course, it's also involved in all computer programs for reflection and it's all not things. But here it's the simplest way of making a videotape. And it shows two different qualities, but these different qualities can only be seen by those people who want to approach to the sculpture as near as possible. So if they are in this distance, the gap is so small only, so they won't see it. They won't see the reflection. And if you appear about in this direction, then the reflected space opens up to them. And if there wouldn't be any video inside, they would just see a reflected space, but they wouldn't see the different qualities of relationship between a simulated video image and a reflected image of a simulation. Of course, there's nothing natural in the thing, just physical rules.
Auw. Nee. Die Twin en het ding die lopen dus zeg maar van de camera weg.
Ja.
Nou, iets doen, dan zeggen ze wat tegen elkaar.
Lopen we naar de deur al.
Is dat jou?